All right, problem number 2. A constant velocity buggy starts at 30 centimeters and moves backwards at a speed of 20 centimeters per second. And it says write down its equation of motion. Let's be clear. For part A here, there's nothing to solve. I'm asking you essentially for the equation of the line that describes the position function of this constant velocity buggy. So if we remember, in general, for an object moving at constant velocity, this is the equation. And let's remember that this is the velocity, which is in fact the slope. And this is the starting point, which is in fact the y-intercept. So for this particular line, this is the starting point, and this is the slope, and let's remember that it's going backwards. So the equation that we're going to write down is going to be x equals negative 20t plus 30. Now we know where the buggy will be at the end of 6 seconds. So to calculate that, we're just going to plug in 6 seconds in this formula that we obtained in part A. So that's x equals negative 20 times 6 plus 30. So it turns out the buggy actually ends up at the negative 90 centimeter mark. So in other words, if we were to lay down a ruler, it would be 90 centimeters behind that ruler. Now it says plot the position of the buggy versus time and use this plot to show that your answer to B is correct. So it looks like you need to end up considerably behind the origin or the 0 mark on the ruler. So I'll start all the way up here at 30. This will be 10. I'm just counting down by 20. Negative 10, negative 30, negative 50, negative 70, and negative 90 right here. And let's go ahead and count time. So this is 1 second, 2 seconds, 3 seconds. I can just count by 2s. 2 seconds, 4 seconds, 6 seconds, 8 seconds, 10 seconds. One thing, I'm just going to be a little strict here and actually label my axes. So this is the position in centimeters, and this is the time in seconds. So we plot. We start at 30, and then 1 second later we're at 10, continuing on. So we're going over 1 down 20, over 1 down 20, over 1 down 20, etc. And when we actually draw this line, doing the best we can, I'll give you rulers in the test. What we see is that we actually do end up at the negative 90 mark at 6 seconds. So clearly our equation and our graph match up. So that's problem number 2.